Have you ever wondered what the sun really is beyond just being our source of light and warmth? Well, let me tell you, it's much more than a big, bright ball in the sky. The sun is a star, a glowing sphere of hot gases, mainly hydrogen and helium. It's located in the outer arm of the Milky Way galaxy, about 26,000 light-years from the center. It's not just any star, though. The sun is special. It's our star. It's the reason life exists on Earth. It provides the energy that drives our weather and powers the photosynthesis in plants. Without the sun, there would be no life as we know it. Think about that the next time you feel its warmth on your skin or see its light filtering through the trees. The sun is more than just a light source, it's a life source. So, ready to uncover the mysteries of our very own star? Let's dive in. The sun may look like a bright, fiery ball from here, but there's more to it than meets the eye. It's a bustling powerhouse with multiple layers, each playing a unique role in the sun's function. Let's break it down. At the heart of our sun is the core, where the magic happens. This is the furnace where nuclear fusion occurs, converting hydrogen into helium, and releasing an immense amount of energy. This energy makes its way outward, through the next layer, the radiative zone. Here, energy is transferred by radiation, bouncing around like a pinball for thousands of years before it reaches the next layer. The convective zone is where things get a little topsy-turvy. The energy, now in the form of heat, creates currents that rise to the sun's surface, cool down, and then sink back down, creating a cyclic pattern, much like boiling water in a pot. Next up is the photosphere, the visible surface of the sun. This is the layer that gives the sun its bright glow that we see from Earth. The temperature here is around 5,500 degrees Celsius. No wonder we need to slather on the sunscreen. Above the photosphere lies the chromosphere, a thin layer that emits a reddish glow, visible during total solar eclipses. And lastly, there's the corona, a super hot outermost layer extending millions of kilometers into space. Despite being the furthest from the core, it's even hotter than the surface, a mystery that scientists are still trying to unravel. Now, what's the sun made of, you ask? Primarily hydrogen and helium. These two elements account for roughly 98% of the sun's mass. The remaining 2% is made up of heavier elements like oxygen, carbon, and iron, among others. So our sun is a complex, multi-layered star, predominantly made up of hydrogen and helium. Pretty cool, right? But hold on to your hats, folks. We've got a lot more to uncover about this celestial powerhouse. Ever wondered how the sun generates its energy? It's an intriguing question, isn't it? Well, let's delve into the heart of our radiant sun to unravel this mystery. It's all about a powerful process known as nuclear fusion. In simple terms, nuclear fusion is like a cosmic dance, where two lighter atomic nuclei come together to form a heavier nucleus. During this dance, a massive amount of energy is released. Now imagine this dance happening not once, not twice, but countless times every single second. That's what's happening in the sun's core, a place where pressure and temperature are so extreme it's beyond human comprehension. The main actors in this dance are hydrogen atoms, the lightest and most abundant element in the universe. Inside the sun's core, these hydrogen atoms are squeezed together under immense pressure and temperature, so much so that they overcome their natural repulsion for each other and fuse to form helium, the second lightest element. But here's the intriguing part: the helium atom formed is a bit lighter than the two hydrogen atoms that created it. So where did the missing mass go? This is where Einstein's famous equation E plus mc2 comes into play. The missing mass is converted into energy, and lots of it. This energy is what powers the sun and makes it shine. The energy generated in the sun's core then begins a long journey outwards, eventually reaching the sun's surface. From there it radiates out into space as light and heat. This journey from the core to the surface can take a staggering 1 million years. So the sunlight that warms your skin today was actually born in the sun's core 1 million years ago. It's truly awe-inspiring to think that the warmth of the sun on our faces, the light that allows us to see the world around us, is all thanks to this incredible process of nuclear fusion happening in the sun's core. So the sun's light and heat that we experience on Earth is a result of this intense nuclear fusion happening millions of miles away. Just like every living being, the sun too has a lifespan. A fascinating concept, isn't it? Our sun, the celestial body that lights up our world, is not an eternal, unchanging entity. It's actually a star which is going through its own life cycle. Currently, the sun is at a stage called the main sequence stage, and it's been burning bright for about 4.5 billion years. Now, you're probably wondering, what's next? Well, The sun is powered by a process called nuclear fusion, where it fuses hydrogen atoms to create helium. But it's not going to have an infinite supply of hydrogen. When it starts to run out, things will begin to change. Imagine this: the core of the sun shrinks while the outer layers expand. Our sun, as we see it today, grows into what we call a red giant. It's going to be so large that it could swallow up the inner planets, maybe even Earth. Sounds like something straight out of a sci-fi movie, right? But hold on, there's more. After expanding, the sun will shed its outer layers into space, leaving behind a hot core. This leftover core is what we call a white dwarf. This white dwarf will then cool and fade over billions of years. So, the sun, as we know it, will eventually become a faint white glimmer in the sky. Now, before you start panicking, let me reassure you, these changes aren't going to happen anytime soon. We're talking about another 5 billion years in the future. That's a lot of sunrises and sunsets away. So why should we care about this? Understanding the lifespan of the sun not only gives us insight into the future of our own solar system, but it also helps us comprehend the life cycles of other stars in the universe. It's all part of the grand cosmic dance. So the sun, as we know it, will change dramatically, but not for another 5 billion years. The sun's influence extends beyond just light and heat. Our magnificent sun, a blazing ball of gas, has an incredible impact on our little blue planet, Earth. Its radiant energy is the driving force behind Earth's climate and weather, and it plays a vital role in sustaining life as we know it. Consider this: without the sun's heat and light, Earth would be a lifeless ball of ice-coated rock. The sun warms our seas, stirs our atmosphere, generates our weather patterns, and gives energy to the growing green plants that provide the food and oxygen for life on Earth. But the sun's influence doesn't stop there. It goes way beyond just providing the necessary conditions for life. The sun, in all its fiery glory, can also unleash powerful solar flares. These are essentially huge explosions on the sun's surface that send energy, light, and high-speed particles into space. Solar flares are part of the sun's weather, and while they may seem distant and irrelevant to our daily lives, they can have a profound impact on Earth's technology. These flares can produce streams of highly energetic particles in the solar wind, which can cause disturbances in Earth's magnetosphere, affecting radio communications, GPS signals, and even our power grids. In fact, a particularly strong solar flare, known as a solar superstorm, could cause large-scale power outages and disrupt our technologically dependent society. Scientists actively monitor the sun's activity to predict such events and mitigate their potential impact. But don't let this scare you. These solar superstorms are rare, and our modern infrastructure is being designed to withstand these solar events. After all, the sun is our life-giving star, and its benefits far outweigh the potential hazards. So from life-giving light to potentially destructive solar flares, the sun's influence on Earth is profound and multifaceted. As we continue to study and understand our sun, we realize how intertwined our existence truly is with this fiery sphere in the cosmos. So, how much do we rely on the sun? Well, let's start with the basics. The sun's light and heat make life possible on Earth. It's the ultimate power source, fueling photosynthesis, which is the process plants use to convert sunlight into food. And we humans in turn depend on these plants for our own nutrition. But our dependence doesn't stop there. We also depend on the sun for our modern technology. Solar energy powers homes and businesses, reducing our reliance on fossil fuels. And the sun's gravity? It's the glue that holds our solar system together, keeping all the planets, including Earth, in their orbits. And let's not forget about the sun's role in regulating our planet's climate. Without the sun, Earth would be a frozen, lifeless rock in space. So the next time you see the sun, remember it's not just a bright light in the sky, but a complex star that our lives intricately depend on.